Here's another example problem, straight off of a past AMCAT. It reads that a prism, which is a 45, 90 degree prism, so it's a triangular wedge-shaped piece of glass or some material, is being used to turn the light path through 90 degrees, so bending like that, using the process of total internal reflection from the inside surface or inside hypotenuse of the prism when the light is at 45 degrees. So the question is, can you use any old material, and in particular can you use crown glass, which has an index of refraction of 1.52 for such a prism? And there's a bunch of choices there. Notice that they all make use of the word critical angle. And I won't read through all the answers here, but let's examine why there's even the use of the word critical angle. So first let's think about what's happening to this light as it's going into the prism and then leaving the prism. Actually, this light encounters three surfaces, and that's an important thing to remember. The first surface is right here. It's when the light is going from air into whatever this material is, let's say glass, and it's doing so at perfectly perpendicular incidence. So if I were to draw a perpendicular line right there, it would overlap with the light ray. And if you remember Snell's law, n1 sine theta 1 equals n2 sine theta 2, the sine of 0 degrees, because this is coming in along the perpendicular and the light is making an angle of 0 degrees with respect to the perpendicular, that sine of that angle is 0, and so the sine of the outgoing angle has to equal 0, and the light is basically unchanged in direction. It goes straight on through at that first boundary. Now at the second boundary, it's coming in at a pretty wide angle. Now I have to draw a perpendicular here as well. I'm drawing a perpendicular to this surface. The light is coming into that surface from the high index side, and it's wanting to refract out toward the low index side, toward air, out this way. But as we know, if the light comes in at too large of an angle, it does not get out at all. In fact, it totally internally reflects. So we have to calculate that effect. How big of an angle is it that the light would totally internally reflect? And none of it would get out this way, and in fact, all of it would reflect back down. Well, we're going to set up Snell's law again. We're going to say n of the glass times the sine of this critical angle equals n of the air, because that's what's out here is air, times the sine of 90 degrees, because that's the largest angle I can have away from the perpendicular. I already know what this n is. It's 1.52 when I'm in the glass. And if I multiply by, if on this right-hand side I have n of air times the sine of 90 degrees, this is 1 and this is 1. So I just have 1 times 1 equals 1 on the right-hand side. So I don't know what n of glass would make for this work, but if I'm trying to shoot light in at the critical angle, I'm going to try it with 1.52. Let's see what the critical angle would be if I want to make it, the light comes out at 90 degrees. In that case, I just divide both sides of the equation by this index of refraction of glass. And I have on the left-hand side, sine of the critical angle is 1 over the index of glass, which is 1 over 1.52. So the sine of the critical angle is about 0.67 or so. If you do use your calculator and take the inverse sine, that turns out to have a critical angle of about 41 degrees. Well, we are sending the light in not at 41, but even a number bigger than that, 45 degrees off of the perpendicular, because you notice this is a right triangle with 45, 45, 90 triangle, and so the light coming into that surface is at 45. Since 45 is bigger than 41, all angles bigger than the critical angle are going to be totally internally reflected, and yes, the light will reflect down because 45 is bigger than 41 degrees. So if I look back at the possible questions or possible answers to the question, it looks like B is the correct answer because it says yes, because the critical angle for crown glass is 41 degrees.